Okay, good morning, friends. Today we are going to discuss very important topic. It is cyclides. So we know that in examinations there is a chance 90% ask question from cyclides. So that's why we are focusing on cyclide and we will explain in a simple manner. So here cycloid means any circular disc is there, or you can take a 1 rupee coin. If it rolls on the horizontal surface, without slipping, and if it makes full complete revolution, and if you mark a point on the circumference of the coin, how the trace forms, okay, that is the cycloid. So here three types of cycloids are there that we will see clearly. So in cycloid, first one is simple cycloid, and second one is epicycloid, and third one is hypocycloid. So now first we will see what is the difference between these three. So if you understand the concept, so easily we can go for problems and solutions of this different methods. So first one is simple cycloid. So what I told that suppose if you take 1 rupee coin, and take the vertical axis line and horizontal axis line. So from the starting point here, assume that this is the ground, and if you mark a point here, on the circumference of this coin, and this coin is rotating in a clockwise direction. This coin is rotating in a clockwise direction. So how much distance it will move? It is depends upon the circumference length. So what is the circumference length? It is circumference length is 2 pi r, or we can call it is pi d. 2 pi r or pi d. This is the length it moves when it completes full revolution. So this coin come to this end means it is completed one revolution. Okay. So this is the topmost point and this is the bottom point, and whatever the curve generates between these two lines only it will generate. Suppose this is half of the distance only it is covered. Assume that half of the distance is covered. So this point how it moves, when the curve goes like that, this point moves and it comes to topmost point. So you can assume that when the half of the distance pi d by 2 length this is. So when it moves half of the distance, the bottommost point it comes to topmost point. So like that curve is forming. So next we can expect remaining half of the curve when it moves from center point to end point, remaining half it comes like that and it ends like that. Okay. So easily we can say that so when it is starting point, curve goes like that and it ends like that. So in examination, sometimes he asks that the starting point or generating point you take on the rolling circle at bottommost point or topmost point. And sometimes he asks that suppose the topmost point takes at the topmost point. That's generating point take at topmost point. Then how the curve forms? This curve comes like that and it ends here at the middle point, and from this point it goes like that. So simply we can assume that how the curve is forming depends upon the starting point taking. Suppose in examination nothing is asking, just to draw the cycloidal curve and the diameter of the circle is given. So then you can take the P point here and you can go like that. Simple process. Okay, this is simple cycloid. The next one is epicycloid. So here epicycloid means in this epicycloid two diameters will give two diameters in the examination. So capital diameter and small diameter, two diameters. One is a directing circle and the second one is rolling circle. Two diameters will give. So if two diameters is there, you can conclude that either it is epicycloid or it is hypocycloid. So how can you differentiate these two means I will explain about first we go for epicycloid. So epicycloid means a bigger circle is there. A big circle is there A big circle is there. Upon that, suppose this diameter of the bigger circle is 100 mm and smaller circle is 20 or 30 mm. Assume that. So with 100 mm draw a circle, big circle, and with small diameter draw the small circle outside of this bigger circle. Outside of this bigger circle. So when the rolling circle rolls outside of the bigger circle, it is called epicycloid. In epicycloid, always rolling circle is outside of the circle. So this we can call it is epicycloid. Epicycloid. Okay, next one is hypocycloid. Hypocycloid means this is also same. Two diameters in examination. Two diameters will give. So first to go for a bigger circle. Draw the bigger circle. Suppose 100 mm diameter, take 50 mm radius and draw a circle. And a small rolling circle, it rolls inside of the circle. Inside of the circle. Okay. So if it is rolling outside of the circle, we call it as epicycloid. The circle, smaller circle, rolling circle rolls inside of the circle. We can call it is hypocycloid. So here the only thing is difference is here. Suppose it rolls in a clockwise direction, it falls down. That's why in hypocycloid it rolls in a anti-clockwise direction. So this is the guiding circle. This is guiding circle, or we can call it is supporting circle. Supporting circle, and this is rolling circle. This is rolling circle. So first one question we will see regarding simple cycle and cycloid and how to draw the cycloid. Okay, first we will see now. So now simple cycloid. First we go for simple cycloid. A simple cycloid of diameter 40 mm. It rolls in a clockwise direction without slipping, and if it makes full complete one revolution, and draw the tangent at 30 mm. So this is the question. So here diameter is given and tangent is given. Now we can go for how to construct this cycloid. Okay. So first diameter is given. So take diameter of the circle. Diameter of the circle, or we can take a bigger one. Diameter of the circle, and take the axis line from the center point. So this starting point, and from here draw the ground or horizontal line, and the length of the line is equal to pi d, or we can call it is 2 pi r length. Full complete revolution. This is the end point. This total length is pi d. If it makes one revolution, means it is pi d length. Okay. Now draw the parallel line, topmost point. So whatever the curve generates by this point between this rectangle box only. So first to draw the limit of the arc. Limit of the arc. So generating point is not given here. So I am taking generating point here. And then divide this circle into equal number of 12 parts. So already we know in the previous videos how to draw the divide the line. So 30 degrees, 30 degrees. Just to divide the equal number of parts. So join all the points. Okay. And give the numbering in an anti-clock direction. Anti-clock means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is point is 12. Okay, give the numbering anti-clockwise direction. When it is rotating, this is the supporting line, and this is the rolling circle. When rolling circle rolls in a clockwise direction, give the numbering in anti-clockwise direction. And from point P to A, assume that P to A length is equal to pi d. Suppose pi means 3.14 into d is diameter. Diameter is given 40 mm. So take 40. So around you will get 125.6 something you will get. Okay. So take 125.6 length. So P to A, whatever this length is there, you can divide directly or you can go for indirect method. Division. Same number of parts. Suppose you are dividing the circle into 12 equal number of parts, then you go for this PA length of the line is also equal number of 12 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then join this all the points to this first last point to P point. So in the previous video you can easily see that how to divide the line or how to bisect the line, how to divide line into equal number of parts. So everything it is there. So 12 equal number of parts you will get. So give me the numbering for this all the points 1, 2, 3, 4, 5 up to 6 and extend the axis line first. It is also parallel line. So all the points vertically extend all the points up to axis line. All the points are vertical only. Vertical means up to vertical axis line, parallel to vertical axis line. So suppose assume that this is center point C. So these all points are C1, C2, C3, C4, C5, C6, same as 7, 8, 9, 10, 11 and C12. So we divided this in for only getting center points. This is divided indirectly for getting center points only. And then go for whatever the circumference points are there on the circle, just to draw the horizontal lines. Draw the horizontal lines. So I am extending all the horizontal line here. So here 12 point is this is 11 and 1. Why? Because this is 30 degrees, this is 30 degrees. So this 2 point coincides. And draw the parallel line. Okay. This 1 and 11 point coincides. And next one is 10 and 2 point coincides. Draw the line. Next is 9 and 3 already it is there. Next point is 8 and 4. This 2 point coincides. Draw the line. And next is 7 and 5. This 2 point coincides. Draw the line. So whatever the circumference points are there, just to project horizontally, and those all the lines should be parallel to horizontal parallel lines. Okay, parallel lines. Now take radius of circle. Take radius of circle is equal to 20 mm. Why? Because diameter is 40. Take radius equal to 20 mm. It is fixed. It is fixed. And C1 is center and cut the first line. Take radius is equal to 20 mm. Radius is equal to 20 mm. C1, keep the C1 is center and cut the first line. So here 11 and 1 line, these two lines is going. Whatever the horizontal line is there, this horizontal line we have to cut. So forget about these all the remaining lines. Only you focus on this blue lines only. This blue lines, horizontal lines. So C1 is center, cut the first line here. C1 is center, cut the first line. You will get here. C2 is center, cut the second line. C3 is center, cut the third line. C4 is center, cut the fourth line. C5 is center, cut the fifth line. C6 center, cut the sixth line. C7 center, cut the seventh line. C8 center, cut the eighth line, ninth line, 10th line, 11th line and 12th line. Suppose choose where 12 is center, cut the 12th point. So if you join this all the points, you will get a cycloidal curve. Cycloidal curve. So this is a very very important thing is you must divide equal divisions. One thing, all the degrees should be equal. So equal divisions, and here P to A, whatever the this circumference length is there, this length also divided into equal number of parts. It is also very important. So after getting this arc, we have to go for tangent. So it is given 30 mm. So from this point, from this supporting line, so take a scale like that, keep the scale like that 0. So see here where you are getting 30. So from this point straight where you are getting 30, just to mark the point. Suppose you are getting this is 30 mm. This is 30 mm. So mark that point name is M. Mark that point name is M. And now once again take the radius of circle. Keep M is the center and cut the axis line. Cut the axis line. So this is radius of circle. This is radius of circle. So you are getting point here. So from here draw the vertical line, and that vertical line should be parallel to vertical axis line, and it touch to the up to the supporting line or up to the ground, we can call it is ground. So now join this line and this M point by a straight line and extend the line. This is called normal, and perpendicular to this line called tangent. So you observe here, first we are getting normal here and then we are getting tangent. But in the parabola, ellipse, hyperbola, eccentricity method, first you will get tangent and then you go for normal. And there the focus point is fixed. And 1 to 1 dash, 2 to 2 dash distance varies. Here it is reverse. The focus distance is constant. 20 mm radius is constant, but the distance center point changes. So these two are the difference between cycloid and conic sections. Okay, this is regarding simple cycloid, one of the method. So next, second method we go for second method. Okay. So here in the simple cycloid, so complete half of the full revolution in a clockwise direction. Okay, horizontally. Last problem we see, and in this problem, half of the revolution is horizontal and remaining half is vertical. Like that also, he may ask question. So half of the distance means we know already. Half of the distance means how much? It is pi d by 2. So pi d by 2 means, suppose you are getting d is equal to 40 mm. So total length, how much you will get? Pi d means 126.7 something you will get. So 126.7 by 2. So half of the distance you take here and draw the circle here itself. So this is half of the distance only. Horizontal rolling half of the distance, and from here this is vertical line. So from here vertically half. So here like that you can extend the line points and here remaining half is this is. So from this center point to this center point, this is pi d by 2. Remaining half is, this is pi d by 2. So this is half distance, this is half distance. So nothing confusion here. So center point to center point is pi d by 2. So this center point to center point is pi d by 2. So this is once again axis line. So instead of drawing horizontally, we are drawing vertically. So half of the curve in this problem, what you have to do? Just you go take the point at the topmost point, P, at the topmost point. So here, instead of rolling completely horizontal, half of the distance is horizontal and remaining half is vertical. And sometimes in examination he may ask that half of the distance is horizontal, remaining half is 90 degrees. So 90 degrees means it is quite opposite. So similar figure. So here the curve from this point means give the numbering clockwise direction. So from this point, suppose this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, and this point is 12. Okay. So these are the numbering. And then when you are starting from point P, so when you take the radius of circle once again and cut the C1 is center and cut the first point. So first point, second point, third point, fourth point, fifth point, sixth point. So if you join these all the points, you will get a curve like that. So this is half of the curve. And remaining half is different. So instead of drawing like that, we are drawing this similar previous procedure only. So from here you see the 1-2 points, you will get a full idea. Suppose up to 6 center is over. Now you are going for 7 center. So what you have to do? So this is center point. And up to this is center point. This is half of the distance. 6 points is over now. So next go for 6 point. This is remaining 6 point is division. So 1, 2, 3. So 1, 2, 3. So here also 1, 2. So this is C6, C7, C8, C9, C10. Okay, this is C10 and C11 and C12. So divide 6 equal number of parts. Or you can go for indirect method also, like that also you can divide. So C6, C7, C8, C9, C10, C11, C12. So how you divided here? Same procedure from this center to this center. Okay. Now C7 is center. So this is C7. Sorry, up to this is C6 now. So this is C7. C7 is center. So we have to cut the seventh line. Where is seventh line here? Seventh line is not there. So just to come to here. So see the seventh line is this is, and where it is touching circumference of circle, it is touching at this point. So mark here 7 dash. Okay, and from here draw the vertical line parallel to vertical line. This is a vertical axis line. Draw the vertical line. It should be parallel to vertical axis line. Like that you have to draw the line. And now C7 is the center. Same once again radius of circle is constant. C7 is the center. And cut the seventh line. So you will get somewhere. You will get somewhere on this seventh line. And next go for 8th. C8 is center. C8 is center. So cut the 8th line. Which is 8th line? This is 8th line. See the 8th line. This is. So where it is touching circumference of the circle at this point. So give the numbering 8 dash. So from here draw the vertical line once again. And that vertical line should be parallel to this axis line. So vertical line parallel to this line. Draw the line. So now change the radius of circle. The 8 is center and cut the 8th line. So somewhere you will get like that on the 8th line. Similarly 9th line. So 9th line is touching here. So give the numbering 9 dash and this is topmost point. So C9 is center, you will get topmost point number. So this curve ended at this point. Once again it starts from at this point only. So join all the points. Okay. So like that C9, C10, C11, C12. If you draw like that, so you will get all the points in this manner. So in this method, simple cycloid, in this simple cycloid, he may ask full revolution horizontal, or half of the revolution horizontal and half of the revolution is vertical, or sometimes he may ask that half of the distance is horizontal and half of the distance is 70 degrees, 80 degrees. So whatever the method, you have to go for this method only. By this method you will get all the problem solutions from this problem. Okay. So next video we go for hypocycloid. So please subscribe and share the videos to your friends. And if anything clarity you want, you can drop in a comment box. So thank you for your support, and we will meet in the next video. Thank you.